Good day everyone, and welcome to Physics Base Camp. I'm Zane, and this video concerns the quantities distance and displacement, two relatively simple values that are immensely useful in a number of physics subjects. Throughout this video, I'll explain what distance and displacement are, and of course, some quick examples with them, though to see them applied in relation to other quantities, you'll want to see some of my other videos. Essentially, what you should get from this video is an understanding of what these quantities are and how they are used, so you can easily breeze through concepts in physics like kinematics, which you can see in later videos. It should be a relatively simple lesson, though of course if you have any questions, feel free to ask in the comments, where I shall answer as many questions as I can, or point you towards where you can find the answer. If you find this video helpful or interesting, be sure to like and subscribe. It is very much appreciated and helps support the channel. Enough talk though, let's get into the video. Just a quick notice before we begin this lesson, some vocabulary you should be familiar with in order to understand what is said is what you see on your screen. You should know what vector and scalar quantities are, and of course be familiar with the idea of SI units, and how units work in general. If you don't know what some of these are, or just want a quick refresh, be sure to check out some of my other videos, which should explain these topics sufficiently. Now for real, let's take a look at what the quantities distance and displacement are. Distance and its close friend displacement are some of the basic quantities used often in many physics subjects, and so it is deeply important to be familiar with them. Distance is essentially how far apart 2 points are from each other. So if we had, per se, two different objects, distance is how far apart those objects are from each other. It is not to be confused with length, which is really just the measurement of one specific object or thing, as you wouldn't typically say the distance of this wall. You'd rather say the length of this wall, because the wall is one object. Whereas if you had two cities, you'd say the distance between these two cities, because they aren't really one object or thing, rather a certain measure between 2 points. So in simplicity, distance is the measure between 2 points, or 2 different things, whereas length is the measure of how long one specific thing is. An important difference, believe it or not. Additionally, distance has nothing to do with direction, or which way an object is going. It really just cares about how far something is traveling in total, which makes it a scalar quantity. If an object moved 20 meters north, then 15 meters east, and then 5 meters south, we know in total it traveled a distance of 40 meters, and we really didn't need to know what direction it went to find that. Thus, distance is a scalar quantity, because again, direction is irrelevant to find distance. Distance only takes how far into account. Distance itself is measured in the SI unit meters, which just means that in physics, we measure amounts of distance in meters, not in inches or feet, etc. It is represented with the lowercase letter d, essentially meaning that just as you might use x or y to represent something in basic algebra, d is the variable in formulas to represent distance. Thus, if you had something like d equals x plus y, d would always represent that value, distance. Now, just to briefly sum that up, distance, a scalar quantity measured in meters, is simply the measure between 2 points, and it is not to be confused with length. Moving on now, let's take a look at displacement, a quantity similar to distance, but most definitely not the same. Displacement is basically how far an object has traveled from its starting point. Not how far it's gone in total, but just how far from its starting point. You might say it's the shortest distance, or the exact distance, between an object's starting and ending points. These definitions tell me that displacement is a vector quantity, because it cares about direction. How do I know that? Well, if an object moved, let's say, 5 meters, and then another 3 meters, how would I know how far that object has moved from its starting point? What if that object moved 3 meters closer to where it started? Or maybe farther? Or maybe a little of both? While we'd know the distance it went in total is 8 meters, we wouldn't be able to find the displacement, because we didn't know the direction of motion. We wouldn't know whether it moved closer to its starting point, farther from it, or anything in between. And since displacement is how far the object has moved from where it began, we kind of need to know this. If instead we'd said something like it moved 10 meters north, then 6 meters south, we now know it made a total of 4 meters north, since it went up 10 and down 6, resulting in a displacement of 4 meters north from where it began. This is why displacement is a vector, because it needs some indicator as to direction. I'll give some examples of this more later on in the video though, so don't be too worried if you're confused. To talk a little bit more about the generalities of displacement, it is represented with the lowercase letter d, just like distance, but since it's a vector, it additionally has a small arrow above that d, just like you see on the slide in front of you. We use this arrow to show it is not the same as distance, and it is rather a vector, something we do for all vectors in fact. Like distance though, displacement is measured in the SI unit meters. Again, just to recap, displacement is how far an object has gone from its starting point, with the direction of motion needing to be specified, measured in meters. A few examples to help reinforce these explanations will be given in just a moment. So now that we've got a pretty solid understanding of what these two quantities are and how they differ, let's look at some examples, not involving other quantities like velocity. If you'd like to see problems where distance and displacement are integrated with other things, like velocity, be sure to check out some of my other videos. Anyways though, as you see on your screen, let's say we are in a car, and we are starting at our house. We then drive 500 meters east to a park. After this, we drive back home, to the west, which is another 500 meters. Let's find both the distance of this scenario and the displacement. Take a moment to pause the video if you'd like to try on your own, though the answers are located on the lower part of the display. Okay, now let's see what the answers are. We know the distance is just the total amount the object traveled, with no regard to direction. So we see it traveled 500 meters to the park, then another 500 meters back, meaning the distance is 1,000 meters, because that is the total amount the object traveled. Now the displacement is, we recall, the distance the object traveled from its starting point. If we look, the car started at the house and ended at the house, so the total amount traveled from its starting point is 0 meters, making the displacement, of course, 0 as well. Now let's say the car only went partially back, getting a flat tire on the way and ending, say, 400 meters west, as it traveled back afterwards, not the full 500. We'd see that the car went 500 meters east, then 400 meters west, meaning the distance it traveled in total must be 900 meters, because in total it traveled 500 meters, then 400 meters. If we think about it, the car would only have 100 meters left to go towards the house, and so the displacement of the object is 100 meters, because it started at the house and ended 100 meters away. Other examples, though, might not just be straight vertically or straight horizontally. Some might involve angles or multiple directions, in which you might want to use things like trigonometry, or the Pythagorean theorem, or even vector addition. To do these, you would typically want to split the distance or displacement into a vertical and horizontal component. However, these things are mentioned in a future video. Nonetheless, let's look at a diagram mentioned previously that we can add on to now. We remember an object traveled 20 meters north, 15 meters west, and then 5 meters south. Our distance, we recall, was 40 meters, since distance is how far the object has traveled in total. Displacement, though, is how far it has gone from its starting and ending points, and is thus the slanted red vector between the points where the object began and ended. To find this displacement, we could use things like vector addition, the Pythagorean theorem, or even trigonometry, though these concepts can be found in separate videos. That said, this brings us to the end of the video. in which I hope you gained an understanding of what distance and displacement are and how they are used. If you understand their meaning, you should be able to easily use them with other quantities in many areas of physics, especially the subject of kinematics, as the only things left unsaid relate to formulas in which distance and displacement are used. These formulas, however, involve other quantities, and thus are talked about in their own separate videos, so feel free to check those out if you wish. Again, feel free to leave a comment below if you have any questions or feedback, and of course like and subscribe if you found this video helpful. Stay tuned for future videos and summer lessons. I'll be making as many as I can, and hope everyone finds them helpful. My name is Zane. Thank you for watching Physics Base Camp, and have a wonderful, wonderful day.